Hello guys, welcome back to our channel. Today we are going to see what is a mux. Mux is nothing but a multiplexer, how it works, and we will see how to make the Verilog code for this 4:1 multiplexer. Here you can observe that we are mentioning that 4:1 mux. That means the mux will consist of a 4 inputs and 1 output, and this mux will consist of a select line. Okay, this select line is nothing but 2 power n select line. Means if we have a 2 power n inputs, we will have n selection lines. That means here you can observe that 2 power n equal to 4, here n will be equal to 2. So for 4:1 multiplexer, 2 selection lines will be there. These selection lines will will decide which input will goes to the output. Okay, let's see how it will be work. In the mux, that means here 4:1 mix means here we will have a 4 inputs. Okay, A, B, C, D, and each having 4 bit size. So 3:0, 3:0, and for all inputs, all are 4 bits, right? So every input will consist of a 4 bits, and another one is the selection line. Here the selection line will be 1:0. Okay, the 2 selection will be there. That means 2 possible connections will be there. Okay, here 1:0 means either 0 or 1, and here we will have a 1 output. Let us see the logic diagram for this 4:1 mux. That means here what are the possible combinations, right? What are the how many select lines are there? 2 select lines are there. Okay, A and B. One is normal, another one is the buffer, and one is the NOT gate. Okay, and here we will have 4 inputs, right? 1, 2, 3, and the 4. These are here for 2 selection lines means there are 2 bits are there. If we have 2 bits are there, then how many possible combinations will be obtained? 2 power n combinations will be obtained. That means 2 power 2 is equal to 4, right? So what are there? 0, 0, 0, 1, 1, 0, and 1, 1. For 0, 0, this input will be given to the output. For 0, 1, this one. For 1, 0, this one. Here 1, 1. Here you can observe 0, 0 means nothing but A bar, B bar. Here A bar, B. Here A, B bar. Here A, B. Okay, here that means A bar, B bar. So we have a 2 inputs. One is nothing but the A bar, and other is nothing but the B bar. And next A bar. Here A bar and B. Okay, and here A and B bar. And next one is the nothing but A and B. Okay, after this, these all are given to a OR gate. And here the expression will be nothing but y is equal to for suppose here inputs are nothing but C, D, E, F. Then the C output will come when A bar and B bar are activated. So first A bar, B bar, and C plus A bar, B, D, and for E, A, B bar, E, and plus F, A, B. Correct. This is the logical expression for the 4 is to 1 mux. By this way, this 4 is to mux will be work, and let us see how to make the Verilog code for this 4 is to 1 multiplexer. Okay guys, now let's start the making Verilog code for the 4 is to 1 mux. So for that I am creating the module with a name called mux, module mux. We require we are going to design the 4 is to 1 mux, right? So we require four inputs and each having the 4 bit size. So I am defining a 3 is to 0, nothing but 0 1 2 3 4. It is 4 bit. Here how many inputs are required? 4 inputs. So a comma b comma c comma d, and we require two selection lines, right? So input 1 is to 0, and we can select as a selection lines, and out for output we again require a 4-bit output because the input is 4-bit, right? So 4 and 3 is to 0 y, and these are the inputs and the outputs we require for our module. Now I am going to give the logical expression for the selection output. So for that I am using the data from rolling, assign y equal to y is equal to selection line equal to selection line of first one. Here we are going to write the ternary statement. Ternary statement is nothing but you can see that as yes, you can see that syntax in the any language will be same. So I'm just seeing the syntax in the C language. Here you can see that if we give the any condition, based on the condition, if the condition is true, the expression 2 will be executed. If the condition is false, then expression 3 will be executed. In the same way as the C language, in the Verilog code also the operation will be same. So I am going for the selection one. If the selection 0, if it is right, if it is false, D will be printed, otherwise C will be printed. And if it is not, selection line 0 and question mark, B is to A, and closing this module. Here you can see that if suppose the inputs are 0 comma 0, 0 comma 0 means here first input is 0 comma 0, in this the first bit is 0. So what this means, if the selection line 1 is 0, that means the statement is false, so it will jump to the second statement. In the second statement it will again check for the second bit. What is the second bit? 100, right? First bit is the 0 and second bit also 0. So 0 means here also selection 0 will be fails, so the A will be printed. As we discussed in the previous, for 00 A will be printed, for 01 B will be printed, for 10 C will be printed, and for the 11 D will be printed, right? So in the same way this code will work. I hope you are understanding this, and we are going to write the test bench for this module. So for that I am creating the module called TB, and I am giving the inputs. What are the inputs registered? 3 is to 0. What are the inputs? A comma B comma C comma D, right? And we have also other input also there. 1 is to 0, which is nothing but the selection line, and we have one output. The output will be represented in the test bench is wire y. Yes, I'm writing all the inputs and the outputs, A comma B comma C comma D. And what are the selection lines? Selection line comma y. Yes, I am going to start giving the test bench initial begin, and now I will give the selection line and what are the inputs and the outputs. Giving selection line is 0 2b 0 0 a equal to, I'm just giving randomly, a equal to 1, b equal to 2, c equal to 3, and d equal to 4, and finally I'm giving some time delay for before changing to the next input. I'm just copying this. I'm going to paste, and here 1 will be the other sequence. Here 1 0, and here is the 1 1, right? Here in the first line the a will be printed, in the second line b will be printed, in third line d c will be printed, in third line, in the fourth line the d will be printed. And the test bench is completed. I am going to write comments, dump file comments, dump file, file.pcd, dump files, on right. Okay. And now here I am going to stop this. So I am giving the command as $finish and giving the end module. Okay. Here we completed the test bench for the Mux module. I'm selecting the tools in the simulator and opening PView, and I'm going to save this file, and I'm giving the, that's right, I'm going to give the name for this module. I'm giving the name as a mux because we are performing the mux operation, right? So I'm again saving this file. As the file is saved, I'm going to run this file. Wait for a second. Yes, we here also in the output state we have to give 3 is to 0 because we in the each output the output size will be 4 bits, right? So I am giving 3 is to 0 here also, and here is the output file. Yes, you can see that the selection line initially is 0, so the first input is come out at the output, and for the 1 b is the coming 2, and for the 2 third input is coming, and for the 3 4 is the coming. In this way the 4 is to 1 mux will be worked. And thank you for watching this video. Stay tuned for the next video. If you have any doubts, please mention in the comment section.